For experiment procedure, the first step, turn on the cooling water supply and mains power supply. Then open the valve for normal refrigeration system operation. Then set the condenser cooling water flow rate to 12 gram per second and keep the evaporator water flow rate constant. Then switch on the unit to start the compressor and temperature display. Allow the system to operate and stabilize for about 15 minutes. Then record the condenser pressure, evaporator pressure, condensing temperature, and evaporating temperature. Gradually reduce the condenser cooling water flow rate, allowing the system to stabilize after each adjustment before recording the operating parameters. The last step, repeat until the cooling water flow rate reach 1 gram per second or the condenser pressure reach approximately 220 kN per meter square.
Next, experiment tools and apparatus. We have main switch, temperature indicator, evaporator water flow meter, condenser water flow meter, condenser pressure, evaporator pressure, condenser, evaporator, and lastly, the cooling system.
So for the experiment variable, first one is control variable, the evaporator water flow rate, which was kept constant throughout the test. Second one is independent variable, the condenser cooling water flow rate, which we manually reduced from 12 gram per second down to 1 gram per second. For the third one is dependent variable, the condenser pressure and condensing temperature, which change as a direct result of the adjusted flow rate.
For experiment expected result, the expected result for this experiment follow fundamental thermodynamic principles. We expect that decreasing a cooling water flow rate will restrict heat transfer at the condenser. As a result, thermal energy will accumulate in the refrigerant, leading to a significant increase in both condensing temperature and condenser pressure. Conversely, the evaporator pressure and temperature are expected to remain mostly stable, as changing the water flow rate primarily impacts the high pressure side of the refrigeration cycle.
Safety awareness is important to prevent accidents during the experiment. Wear proper clothing including footwear. We had ensured all water line connections were secured before turning on the power supply to avoid any electrical hazards near the equipment. This experiment supports SDG 7 and SDG 13 by understanding how the cooling water flow rate impacts the system's coefficient of performance. We can optimize the industrial HVAC systems to reduce overall energy consumptions and lower carbon emissions.